would have been here when I mute everybody at once. Just mute your mic. Okay. We don't have much time. So the little time we have, we should try and use it well. All right. I stopped here somewhere around here yesterday. And like I said, most of these things I'm just showing you because the aspect that you might be required to put down something to write, yes, that's where this will come in handy. Yeah, but the actual explanation to some of these things are what I'm going to is my next part of call. Okay. So I know you are seeing forward pass, but let me go back and see what I have before this one. Okay. This is what I have here as well. Okay, I think this was where I stopped yesterday. So I said steps in developing a project network. 1, identify all activities and list all tasks required to complete the project. Number 2, determine activity sequence. Identify which activity depends on others. Number 3, estimate activity durations using what we talked about yesterday, CPM or PERT approach. And number 4, we talked about how to draw the network itself, the network diagram. And to draw that, you require nodes and arrows. Those are the 2 key things that you require. And I tried to show you an example yesterday. However, we will be doing more of that today. So meaning of network analysis. We say network analysis involves systematic examination of the project network in order to determine the duration of the project. You want to know how long the project is going to take or is going to last. How long are we going to, does it require for us to complete a project? You get that through this analysis. Okay, you also identify critical activities using network or network analysis. You'll be able to allocate resources efficiently. These are some of the what network analysis can do for you, and also control project progress to know how much progress we are making on a project. So when we talk about forward pass is just simply when you start a project, the beginning of when you are taking your drawing or your diagram, and you are taking calculations from the beginning of the project.
More shoes.
Your focus is from the beginning of the
Lagos Island. They are holding 100,000 more than safe. You know how much their things are. You know what shocked me that day that I went with that 50K? What we bought?
Can you please mute your mic? I don't know that person.
Like it's small now. Assuming it was then now.
Before Tinubu entered now.
At that time that I used to go, 50K would have bought me how many things? You remember 2023, 2022?
What did you buy? 2 joggers for 1 shoe.
1 shoe, 50K. 2 joggers, 1 shoe. Everything was 50,000. Not buy anything else. Nothing, even shirt.
So the mistake from 100 level, you are still in 400 level, you are still doing the same rubbish.
Stop making noise.
Stopping the lecturer and the rest of us in the class.
I've taken his matric number. I will not be saying anything again. I know what to do. So if you see the consequences of your behavior, next time you will not behave like this again. You put on your phone, you bought data, you saw the link, you use the link, you will not conform to what they ask you to do. If you know you want to discuss, don't just come, go and discuss. Yeah. All right, so I said for forward pass, you are looking at the beginning of the project. You are taking stock from the beginning of the project towards the end. Okay, so your movement from the beginning of the project towards the end. So, and we are going to start with your earliest starting time, which is the EST. the earliest starting time of the first activity often is always 0. Okay, it's always 0. I'm going to show you that soon. Let me hide this. Okay, we have the earliest finishing time. That means the earliest time it will take for the activity to finish. The earliest time it will take for the activity to finish. And it is the earliest starting time plus the duration. Now, when we start to talk about EST, EFT, LST, LFT, sometimes these are the areas I have seen that students may have some challenge with. Today, I will try my best to teach you my own way. You will not see this anywhere elsewhere because I also saw it. I said, okay, which if you go read most textbooks and so on, is still the same. So, but maybe my own method may help you find it easy to get used to it. Okay, so what we'll get there. Forward pass from the beginning to the end. And when you are moving from the beginning to the end, what you are simply trying to do, you are simply trying to what? Add. You'll be adding each time for each activity. You add it to give you the starting time of the next activity. Just like that until you get to the end. I will show you that later. So you move from the start to end of the network, and the purpose is to determine the minimum project duration. The minimum project duration. So the backward pass, for the backward pass, when you get to the end of the project and you are returning back to the beginning, why? The purpose for that is to get our latest start time and latest finishing times. Okay? So for forward pass, your interest is the what? Earliest times. For backward pass, your interest or focus is the latest times. All right. So for this, you have your LFT. LFT is latest finishing time of last activity. Is equals to what? The project duration. Latest finishing time of the last activity is equal to the project duration. All of this will not make sense to you now. Just hold on. Latest starting time is equals to the latest finishing time minus duration. So when you are going back now from the end of the project, you are going back to the beginning because there are two different figures you have to get in order for you to determine a lot of things that we'll be considering later. So one of the figures you get while you are going forward, the other you get while you are coming back. Okay. The move, if you realize the backward pass, you are saying what here? Negative is minus. Okay. The forward pass, you are saying positive. So you move from the end to the start. So the purpose is to determine allowable delay, because there are times you run a project and one or two things might happen and that might require the project to stall a bit. So however, those delays are such that they should not affect the overall completion time of the project. So, and this is where we talk about floats. And I said floats is just the spare time that you have in running an activity. Okay, the spare time that you have in running an activity. We have what we refer to as total float, which is LFT minus EST minus duration. We have what we refer to as free float. I'm going to limit you to just 3 types of floats. Okay, so time and activity can be delayed without delaying the next activity. The time and activity can be delayed without delaying the next activity. And the formula for that is EFT minus EST and minus duration. And the final one, okay, I didn't put that here. I'm going to add it later. That's supposed to be independent float. So the importance of float, it helps to manage flexibility and it supports resource leveling. it supports resource leveling. So it also prevents unnecessary panic or non-critical delays. When you have an idea of the spare time that you have, take for example, you're preparing for an exam as your project, and your exam is going to kick off maybe on a Friday, and today is Monday. So you have 4 days to your exam. So within those period, you have some, depending on how your preparation is. Okay, you have some flexible time to do what you need to do. You know that maximum, the time you have, the float you have is Thursday. By Thursday, it will be too late for you to say you want to do any other thing. You have Monday, Tuesday, Wednesday to do what you have to do. But on Thursday, you must be prepared for your exam. If you have just 1 day to read for that exam that is going to take place on Friday, okay, so you have 3 days to do whatever you want to do. Anything beyond 3 days is going to affect you. So that's what float is really trying to talk about here. So, but practically, you appreciate it when we start to solve problems. So critical path is the longest duration path through the project network. Characteristics, we say it has 0 float. It has determines project completion time. Any delay on this path delays the entire project. Okay, so most times in the exam, what we ask you to do first is to find the critical path. That's one of the most important questions that you'll be asked. And for example, we say in a federal road rehabilitation project, delays in asphalt supply, drainage construction may be critical, while landscaping may not be. So advantages of PERT and CPM: it improves planning and scheduling, it enhances time control, it identifies critical activities, it supports better decision making, improves coordination, reduce risk of project delay, and their limitation of PERT and CPM. Accuracy depends on what? Quality of estimates. Accuracy depends on quality of estimate, especially for PERT. So they can be complex for large projects. They can be complex for large projects. They require expertise and regular updating. Okay? They require expertise and regular updating because as you embark on your project, things may change. What you have estimated before to take you 3 or 4 days, you realize that you may have to make adjustment to it again. I'm talking about in reality now. So it does not automatically resolve resource constraints. So when we have challenges with resource during your project, running your project, it does not automatically resolve that. What is only after is to set you in motion to make sure that you are able to schedule your project in accordance with your time. So if you have shortage of money, there's nothing this can do for you. If there's shortage of manpower, there's nothing this can do for you. Or there's a policy that is going to affect the project, this cannot help to checkmate that or take care of that. Okay, I think I'm going to leave some of these things for you guys to read later so that we just go straight. Summary of everything is here. Visualize project activities. Developing project network using PERT and CPM enables project managers to visualize project activities, identify time critical tasks, manage uncertainty, minimize delays and overruns. Network analysis provides the analytical foundation for effective scheduling, monitoring, control of complex projects. So let's see some numerical worked examples quickly. I'm going to give you the notes maybe today or so. Let's see this. Okay. Okay, so the following data of PLJ and Sons Limited represents the various activities and durations needed to execute a local road project in Edo State, Nigeria. Like I mentioned yesterday, this surely will be given to you, no doubt, And there are some questions at times you are the one that will come up, break. We will give you the activities in Word. So you are the one that will now pick those activities and itemize them this way. So I'm not really sure where the pattern will go this year. So, but for now, let's work with this. You have activities here, A, B, C, D, E, F, G, H. Each of those activities may represent something. Who is that person? Please mute your mic. Please mute your mic.
Oluwole Tayo, please mute your mic.
So each of these activities may represent a particular task, okay, for the road project or the road construction. All right, so we'll leave that aside for now. Let's focus on what we've been given. Now, when you observe very well, you realize that for activity A, activity B, and activity C, you can see very clearly that they have no what we call predecessor. Predecessor means an activity that happens before an activity happens. A is an activity. There's nothing that's happening before A. There's nothing also happening before B. There's nothing also happening before C. So they have no predecessor. So in that case, what do? When an activity has no predecessor, you have no problem. It even makes your case very easy. So what we are saying invariably is that, let me see how I can squeeze in this now. Okay. Required, using the information provided in table 1, draw the network diagram for the project. Determine the critical paths. Determine the minimum time required to complete the project without delay. Determine the following float for each activity: the total float, the free float, the independent float. Then additional tasks, well, we can also talk about this as well. Using the network developed, you have to calculate the earliest start time, the earliest finish time for each activity, and as well as calculate the latest start time and latest finish time for each activity. Okay, then you also have to identify the critical activities and non-critical activities. Explain the significance of the critical parts in a project management. So the most important aspect to me right now is, let's start with even drawing the network diagram. This table you are seeing is the same table you saw before. So we see that activity A has a duration of 2 months. It will take 2 months to finish activity A. And I just told you that activity A has no predecessor. Activity B will take 3 months. It also has no predecessor. Activity C has no predecessor as well, and it will take 8 months. So what you do is you draw your node, because every of this activity must begin with a node. And I showed you yesterday that a node is just a round circle. It's a node. Okay? You draw your node. The node is the starting point. If you like, you number. You like, you don't number. But in this case, let me just number so that you know that this is our starting point. Let's give this 1. All right. So since there are 3 activities without a predecessor, that means 3 activities must come from this node. The first activity, you draw the arrow. As you draw the line, you must draw the arrow, and then make sure you close it. You close it with a node. You close with a node. If you like, it's optional. For this one, it's optional. You can also number this as 2. Okay? And then we know that right now we have, this is going to be our activity. We can give this activity A. This is A. Okay? So if this is activity A, we said activity A has a duration of what? 2 months. So you can leave your 2 here. If you like, you put it in brackets or you leave it this way, whichever is convenient for you is okay. The next activity we are going to look at is activity B, which is going to also come from this same node. But mind you, when you are drawing your network diagram, I always like you to use pencil just in case you make mistake, because you will surely make mistake. You might have to be cleaning, okay, because you might have to readjust the diagram from time to time. But to reduce errors while you are drawing, you can also look down. When you look down this way, on this column, you look down this way. Take note. From row D, activity D here, you can see that it's going to start from A. Activity E is also going to start from A. It's telling you in advance that 2 other activities will begin from A. If you come to F, you realize that activity B has something to do with F as well. But when you see two different activities, B and D, it's indicating to you that B and D eventually, in the future, as you keep progressing, they are going to meet at a point. B and D are going to share one node, as in they are going to meet at a point. When you come down to H, you also see that at some point, C, F, and G will meet at a point. Well, for now, let me not bother you with that, but I'm just trying to show you this so that if you want to start drawing, you will minimize your mistakes and your cleaning. But for now, since you are just learning, let's leave that aside. Let's just go as we come across the activities. So we've drawn activity A. The next activity we are going to draw now is activity B. But if you notice, I'm drawing it a little bit longer. And there's a reason for that. Because I've seen that in the future, B is going to meet with D somewhere. So I have to move it ahead. Okay? So now, after drawing this, I close the arrow here. And I come here. I quickly state it here as my B. This is B. And B has a duration of 3 months. I leave it this way. By choice, if you want, you can as well give this node 3. The third activity is activity C. Activity C can come this way. And then you draw your arrowhead and seal up this activity with this node. You come here and then put your C here. We say C has a duration of what? 8 months. You are done with ABC. You are done with ABC. At this stage, is there any question, any area that is confusing here? Is it clear?
Good evening, sir.
Yeah, good evening.
Yes, sir.
Okay, so the area I'm confused about is the relationship. What's the relationship between the activity B and D?
Yeah,
You
we'll
said,
get there. Don't worry.
yes, sir.
We'll get there. Maybe I'm not supposed to even let you know now so that it don't get you more confused. Just hold. So,
Good evening,
Hello, sir.
sir.
Please, I also want to
Sorry.
ask, sir.
okay, please go ahead.
Hello, sir.
I'm with you.
Please, the length of the arrow. How do we determine the length of the arrow
The length
and
of
the closeness?
yes, the length of the arrow don't necessarily have to be everybody don't have to have the same length. It's subjective to you. However, it is convenient for you to draw it as long as you are able to properly capture what is on the table. So I've chosen to draw my own this way. You could draw your own in any other form, but however, at the end of the day, we'll have the same shape, the same figure, and the information on the table must be well reflected in your diagram. That's what matters.
Yes, sir.
All right.
The positioning, does it matter?
Positioning really doesn't necessarily matter, but by convention, when you are going forward, you always move from right to left. So, and secondly, mind you, you have your paper that may not be so wide for you to start drawing gigantic diagram that will fill the whole place. What matters is that you are able to show all the figures that is on the table. Okay, so
Hello, sir.
yes, I'm with you.
Yeah, I observed that the first table is different from this table from which we are doing this, and what's it called? This diagram. We are drawing this diagram. The
Okay.
first table is different from this table here. And I could remember you said what's it called? The items in that first table is still the same, are still the same items in this table.
How is
Yeah.
it?
This
How is
table.
it different here? What's the difference?
I think the column is not as much as this now. It's not as many as this in the what's it called, the other one, and it is longer.
The only thing is that the diagram here was transposed. I brought what you have on this column to become your title. Here is the same information. What you have
Okay.
in column 1
Okay.
is what you now have in your rows.
Okay.
Yes. Any other question? All right, so let's move on. So now you have A, B, and C satisfied. Activity D here. Activity D. We say it has 4 modes. And if you look at it now, activity D is coming from activity A. So the predecessor of activity D is activity A. Okay? Hope your governors are here, because if they are not here, I won't be able to restart this meeting if it stops. I have to send them the link to share to you. Governors, Governor Shitu, and Vincent. They weren't around yesterday, and I hope today they don't also miss today. Okay, so now we want to draw activity D. In case we go off, I'm seeing I have like 10 minutes more. I would send another link to your governor. I hope he gets it across to you. So now, activity D, we say it starts from what? Activity A. But observe, despite the fact that it starts from activity A, when I said when you go down this way, you will realize that it meets with B at a point. Okay, activity D meets with B at a point. If you don't know this, you can as well draw it, but at the end of the day, you have to clean and start again. So what am I trying to say? This is activity A, this point here. That's where it stops. So we are picking D from that point, and we are picking D to meet with B here. All right. So now this becomes our activity D. And we said D is what? D is for 4 months. Okay. So ordinarily, I would have just drawn D this way. I would have just drawn D. I don't know where D is going to. I would have just drawn it. Then later realize that, oh, D is supposed to touch with B. So you have to check the columns down and see, does D have any relationship? Where is it going to stop? Is it going to link up with previous activities that have started before D began? So we have our D drawn this way, and we said D is 4 months. Okay, then the next activity is activity E. Activity E again begins from A. Activity E starts from activity A. So we move this way. Sorry, I'm using the wrong color. We move this way. Maybe I can extend it a little bit more. And then we close the node this way. So this becomes activity E. And activity E is 6 months. That's the duration. Okay. The next activity is, mind you, we have not been numbering the nodes. Let's give this 4. And let's give this 5. This should be 5. So the next activity is activity E. And activity E is also okay, I've drawn that already. Activity
F.
F. So activity F we see is beginning from the point where B and D touches. So activity F will come from here forward this way. And then I close. You see now, the length of my arrows may, at the end of the day, affect my paper. But because I'm explaining to you, I want you to see everything clearly. So this becomes our activity F. And we say activity F is 5 months.
5 months.
So the next activity is activity G. And activity G starts from what? Activity E. But take note, when you look at activity G starting from E, activity H, you realize that there is a link between F and G. So therefore, where activity G is going to stop, it will stop with activity what? F. So you draw activity G down this way to meet with F here. Then you close with your arrow. This is your G, and G we say is 4 months. We can as well give this note 6. Now, the last activity is activity H. Activity H can come this way. I'm going to make this a bit shorter because of my paper here. Activity H comes this way. I draw this and I close this node here. So this becomes my H. This becomes my
Hello,
H.
sir.
Yes, please.
But when you wanted to draw this activity F,
Yes.
you said it started, the predecessor is B and D.
Yes.
So you started from B and D, the point where B and D met.
Yes.
So, but this H now,
Yes.
it started from C, F, and G.
Yes.
C, F, G. So, and C is down here. That's node 4.
Okay.
I think the node should touch both C and this F and G.
I don't get you.
I mean the what's it called? For this activity H.
Yes.
I mean the node, since you said it has to touch the 3 points
Yes.
where those what's it called? Those predecessor meet.
Yes.
Fine. We know that C did not meet here, did not meet where G and what's it called? G and
From our drawing.
F.
Yes.
But I think drawing from this, I think the activity H should come from C to this place where F and G meet.
Very good of you. Very good of you. So I purposely want to hear your perspective, how you took note of this. So what if we leave it this way? What is wrong actually? Because it is shown on the table that we have C, F, and G. Now, what we do, you are right. I don't know your name, but you are very correct. What we do in this case,
I'm Daniel, sir.
Okay, Daniel, fantastic. What you do in this case is where we introduce what we refer to as dummy activity. Okay, a dummy activity, we call it an activity as well because we just use it to complete the network diagram. Now, we have C, F, and G meeting. They are supposed to meet at this point. Okay, but if you look at, there's no way we could have drawn C directly from here to this place. It becomes parallel with, yes, so it doesn't work that way. So what we do when you get to this stage, to close this up, you make use of a dummy activity. And how do you do that? You represent it with broken or dotted lines. This is not exactly the arrow. The arrow is broken. So this activity here is usually designated 0. Okay, this doesn't take any time. It doesn't take any resources. Sorry, I'm using the wrong color here. So this is a dummy activity. Let me put it here. Dummy activity. We are just using this to connect C to what you have to this node here. So very good observation.
Sir, what does that dummy activity mean, sir?
I just explained it now. Yes. It's an activity that consumes no resource, no time, no nothing. It's just we use it by convention to make sure that you don't have two nodes ending the network diagram. Every network diagram must end on a node. So, but if you delete this one now, you have node 7 and node 4 being exposed. So everything should be linked to a particular node. What should end this network is node 7. And more so, you have it on the table that there's supposed to be a connection between CF and G. So, but in reality, it doesn't work that way. So we have to use a dummy activity to connect all of them. So for at this stage, you have, in case I go off, I'll be going off in less than a minute. At this stage, you've gotten some mark. But we've not started anything, no. We just drew the diagram. So now, with this information, you can then start to do the rest activity. So please. All right. So at this stage, you have drawn your diagram. This is a network diagram. But however, all the informations are not, we cannot decide now fully to get what we've been asked to look for. We've been asked to look for critical path and the rest. Now, remember, I mentioned forward pass. I'm not going to, load you so much that at the end of the day, you cannot be able to handle that. Thank God we still have some time. So as the day goes by, I'll be doing my best to be coming more frequently so that gradually we keep doing it until we get used to it. So now, starting from the beginning here, this, please mute your mic, please. Just mute your mic, please. This is the beginning of our journey. And we always say the first, the starting point is always 0. The starting point is 0. This is where the project begins. Okay? So from this point 0, which is at the tail of A arrow, activity A, to the head here of activity A, what can you see? You see the duration is 2. So 2 plus 0 will give you what? 2. You put your 2 this way. Okay? So, and then when you move again, please follow me carefully so you don't miss this part.
Sorry, sir.
Yes, please.
Please, can you come again, sir? Like, can you start from the beginning again, sir?
I said by convention, this first node 1, is your origin, your beginning. So we always will designate it as 0. This way we are starting from point 0 here. So from the tail of activity A to the head of activity A, the duration is 2 months or thereabout. So you have 2 plus 0 plus 2 will give you this 2 that we have here. Okay? Yes. So what does this represent? This is only trying to do this is showing what this is your earliest starting time. This is for this. As a matter of fact, let me even start to introduce that now. What the figures we are picking now is our starting times. Okay? And our finishing time. Please, I want to do 2 things at the same time. Please. The first one we get, this 0 that we got here, is the starting time for activity A. This 2 you are seeing here is the finishing time for activity A. Activity A alone, please mute your mic. Activity A alone has both 2 times now, the starting time and the finishing time. Okay, the starting time and the finishing time. The only thing you can introduce now to this is E. When I bring this here, it becomes earliest starting time. Earliest starting time for activity A is 0. Okay, and then the earliest finishing time for activity A is 2. So all the numbers, all the figures we'll be getting now are the earliest time. And this is what we refer to as what? The forward pass. We are moving forward now. We are going forward. We are going forward. We are going forward until we get to the end of the project. Okay? So 0 plus 2 will give you 2 here. Then from node 2 to node 5, which is activity E. From node 2 to node 5, you have duration here is 6, which is 6 months. Now you say 2 plus 6 will give you what here? It will give you 8. You come back here between node 2 and node 3. Please look on your screen. I don't want to be touching it all the time. Between node 2 and node 3, you have 4. Between node 2 and node 3, you have 4 months. But mind you, you cannot just say this 2 plus 4 to give you 6 here. You have to confirm something. Please follow me. This is where most of us miss it. There are 2 activities that stops at this node. Activity B stops here, and activity D also stops here. And now we are on the forward path. We are moving forward from the beginning to the end of the project. Now, which of them are we going to pick? If you say 2 plus 4, it will definitely give you 6 here. If you say here, 0 plus 3, this is 3, it will give you 3. So we are having 2 conflicting numbers. So what we do by convention, the rule is that when you are having your forward pass, when you are going forward, when you do your addition, the number, the higher figure is what you select. The addition that gives you the higher figure is what you pick. So in this case, we have 2 plus 4, which is 6. So we are going to put 6 here.
They're not sharing it.
Please mute your mic, please. Oh, mute your mic. Mute your mic. Okay, so that is done. Let me put it properly so we don't miss it.
So please, can you explain that part again?
Okay. As you've asked your
The
question,
activity B at that of
yeah, just mute your mic. After you finish talking, just mute. I easily get, I don't know, I just don't like that sound. Now, I said when you have 2 activities, like you have now, activity D and activity B, this line, this arrow is for activity B. This arrow is for activity D. Both of them, they are sharing this particular node. Now we are having what we call the forward pass. We are beginning to add durations. We are going to, in this case, we are having 2 conflicting numbers. How? The tail of activity D begins at 2, month 2. 2 plus 4 gives us 6. Activity B begins from 0. This is the beginning, 0. 0 plus 3 gives us what? 3. So I said the rule is that you always pick the addition that gives you the higher figure. Is that clear? So we pick 6. Is that clear? The person who asked that question.
Hello, sir. Hello, sir.
Yes, I'm with you.
Why?
No,
Why
sir.
if we don't add activity D to D? 3 plus 4.
No, you can't do it that way now. We are going by, okay, look, whatever question you ask me is, no matter how don't feel embarrassed. Feel free with me. If you ask me anything, I'm here to answer you.
Hello, sir.
Yes, but take it
Sir.
step by step. Okay, let me hear
Sir.
you. Yes.
Sir, this activity B, the notes, they wrote one there.
Where?
The beginning of activity B, they wrote one inside the notes.
Okay. Just hold on.
But you said it's 0.
Yes,
So there is conflict there, sir.
All right. Very good. If you didn't speak up now, I will not know you have this challenge. Let me come again, please. For the last time, just listen to me. These numbers I wrote inside the cycle, the nodes. I said I'm doing that so that it will be a bit easy for me to explain to you. You can put it, it's good, but if you don't put it, no problem. We are not using any of these numbers to do anything. They are just there to show us where one activity stops and the other one starts. That's just what they are doing. Nothing. They have nothing, no role to play in your calculation. So stop looking at these figures. They have nothing to do in terms of what we are doing now. The 0 I'm telling you about is this 0 you are seeing here. Oh, maybe because sorry, let me write it properly. This 0 here. This is 0. Okay. I said it is 0 because this is the beginning. A is starting from 0. B as well is starting from 0. C as well is starting from 0. So any addition you want to do around B, you must consider this 0. So likewise, I started by saying that this 0 simply means the starting time for activity A, B, and C. That's the starting time. And if I want to go further, you can call it the earliest starting time, because there's no other earlier time than this. So the earliest time activity A, B, or C can begin is this at point 0. So we say activity A now has 2 months to get completed. Okay, so if activity A starts here, it will end here at this node. And how do we know what will be here? Is 0 plus 2 gives us 2. Now, automatically, this 2 that you are seeing now becomes the starting time of activity E and also activity D, because both of them are coming from A. So this 2 up now becomes the new starting time for activity D and activity E. This is E and this is D. So coming back again, like I said, from this point here to here, this is activity B. It stops at node 3. Activity D as well stops at node 3. Both of them have different durations. They don't have the same durations. Both of them have different starting points. They don't have the same starting point. So definitely they will have conflicting numbers here. So I said, if they have conflicting numbers, as long as you are moving forward, you are doing addition, always go for the addition that gives you the higher value. So I said 2 plus 4 equals to 6. Here, this 0 you are seeing up, plus 3 equals to 3. 3 is less than 6, so we pick 6, and then we move on. So we discard this one now. We'll just keep making our movement. Now, if you can choose wherever you want to start from. I can choose to come down here and do my own here. I can continue this way or go this way. Okay, so but now let's start from node 5.
Sorry, sir. Hello, sir.
Yes, please.
In order for me not to bring you back later, now considering the earliest starting point for activity B now,
Yes.
will the earliest starting point still be 0 and the
You don't finish your
and
3 days.
Let me go and so that you can see
If you ask, if you've spoken before, just mute yourself. I don't know who is speaking.
Daniel, sir.
Okay,
Daniel,
go
sir.
ahead.
It's Daniel.
Yes.
So now, looking at from your explanation now, the earliest starting point for starting time for activity B will be 0, and
Yes, correct.
the earliest finish time now, will it
Yes.
still be 6 or it will be 3? Because we are not considering the lowest addition now. We are
God
considering
bless
the
you.
highest.
God bless you. Thank you for that question. Now, this is what results to what we refer to as float. Float. float, for example, like I said, your exam is on Friday and you have some spare time. So if you look at this activity now, if we are saying it's finishing time, automatically will become 6. Yeah. So meaning that we have some 3 months float for activity B. Okay, its finishing time based on this our calculation now will become 6 months. However, it's not this may not be its own earliest finishing time. And that is why I said because of the float, when you start calculating your float, that's when you realize that okay, B can actually finish before 6 months. And that is true because B is what has a duration of 3 months. So that observation is quite in order. So moving forward, please mute your mic. Don't distract me, please.
Yes.
Hello, sir.
Yes, Daniel.
Hello, ma.
So now, the conclusion is we take 6 as the earliest
6,
finishing
yes.
time, right?
Yes. For this mode.
Okay, so we consider this 3 as the float.
Not yet. We'll
Not yet. Okay.
come to
We
that
just
later. Please, that person whose mic is on, please put off your mic now. You can hear my voice. If you know your mic is on, just put it off. If you're not here, sure, check.
Okay, make a call this.
Not doing anyone. Not doing their own kingdom. Not doing anyone.
Adebayo, your mic is on. Can you mute yourself, please?
Okay, so let's move on. Maybe after the whole thing, you can then ask your question. So we see where we are heading to. So now we have 2 plus 6. We have 8 here for activity E. Okay, this is the finishing time for activity E. This is the starting time for activity E. When you come here for activity G, the starting time here, we are seeing 8. But watch again. For this activity, we have several activities, about 3 of them. Activity G, activity F, and this dummy activity here that represents C. However, this is a dummy activity, so we can't even mention C around there. It's just trying to link up this. So we have 3 different activities, 1, 2, and 3. I said earlier on that when you do your addition, the one that gives you the highest value is what you pick. So here you have 8 plus 4. 8 plus 4 will give you 12. When you come here, you have 6 at the starting point for activity F. 6 plus 5. 6 plus 5 will give you 11, which is not up to 12. When you come here, we can say this is 8 because I've not even done this. Since this starts from 0, the finishing for C will be 0 plus what? 8. So here you have 8 here. This is 8 for C. So 8 plus 0 will give you what? It will give you 8. So at the end of the day, we have 12, we have 11, and we have 8. We are going to pick what? What are we going to pick now?
12.
Activity G.
12.
Very good. So we have 12 here. Okay, so now we have 12 and plus 7, which will give us 19. So we just finished what we refer to as the forward pass. What you have gotten so far, all the figures you have are your starting times and finishing times. In terms of earliest starting time and earliest finishing time, all the earliest times are what we've gotten. We need to look for the latest. Okay, you've gotten all the earliest from 2, right from 0, 2, 8, 12, 19. We also have here 6. We have here as 8. So now, what do we do? If you remember, if you can recollect the slides I was showing you earlier on, I said when you get to, let me put this properly because you might want to make reference to it later and you are not sure what I wrote here. This is 19. When you get to the end of the project or the last node, what you do is you make this equal. So you're having a number up and down. Okay, please hold on. Let me finish, please. You have two numbers now, one up and one down. Okay. Automatically, since if you started from zero, at this point. By convention, here is always 0. By convention, the last earliest times automatically will be the same thing as the first latest time. This becomes your first latest times. This is your last earliest time. So 19 over 19. That is by convention. You don't even need to ask yourself anything. You get to this point in the exam, you just do it the way I've shown to you. So now when you are going, which is the backward pass. I didn't get you.
I said, please, is that you are explaining 19 over 19? Please, sir, explain it again, sir, please, sir.
Okay, the simple explanation here is that whatever you get as your final answer up here, just bring it down. Whatever you get as your final answer here, bring it down. It must be the same. The two
Thank you, sir.
must be the same. Yes. So 19 now, you are going back now. When you are going back, we start to minus. 19 minus 7.
Hello, sir.
Hello.
Hello, sir.
Yes.
Yeah, you said whatever we get as our final answer, we bring it down.
Yes.
This is fraction here. Like, is that the what's it called? The convention.
Do you know what? Don't stop me again. Just let me finish. Like you rightly said, yes, that is the convention. We are not doing any fraction here. No. The division or demarcation, that's just a demarcation line. It's not a division line. Showing you the earliest starting time and the latest starting times. That's just it. So you have 19 minus 7 will give you what here? It will give you
12.
Correct. It will give you 12. Okay. Now, if you observe, you are saying that we are having at node 7, we have equal starting time and finishing time. We have the same thing here as well, 12 over 12. Now, we are going from this node to this node. Here, we look at now. Please, going backward, forget about everything you have up. You have no business with all the numbers up anymore. Your attention is all the numbers down. All the denominators. I'm careful not to use that word because this is not a fraction. So all the numbers down are your focus. All right. So 12 now minus 4. We give you what here?
8.
8. Now you see, we also have equal numbers here. The earliest starting time and finishing time for this as well. We are having the earliest and latest here is the same. Okay. Now, this same 12 minus 5 here give us what here? 12 minus 5 will give us 7.
7.
Good. 12 minus 0 will give us what here? To give us 12. Good. Okay. So getting to this point, you have 7 here. And remember, we have this node going this way, this one going this way. No problem. In fact, our backward pass, we have not had any issues so far, so good. So 7 minus 4 will give us what? 3, right?
3.
But watch out. Just watch out. There are 2 activities that proceeded from here. Watch out, okay? 2 activities. if you say 7 minus 4, let me put it here. Just write it down. This is 3. Okay? And then this other activity is here as well. Here, you come here and you say 8 minus 6 to know what we are going to get here. 8 minus 6 will give us what? 2.
2.
So when you are going back, the subtraction that gives you the lowest value is what you pick. When you are going forward, the addition that gives you the highest value is what you choose. When you are going back, the subtraction that gives you the lowest value is what you pick. Now, between 7 minus 3, 7 minus 4, which gave us 3 here, and then 8 minus 6, which will give us 2. Of course, going by that rule, we are going to pick what? 2. Is that clear?
Yes, sir.
Okay, thank you. So, you see at this point as well, we
So,
have,
sir,
yes, please.
that means when we are going backward, what we deal with is the original time duration is what will be minusing. That is the figures.
I don't know what you are defining as. Yeah, of course. Yes. Now, yes. Correct. You're right. Yes. You minus what you have as the duration, time duration. Very correct. So now at this point, we've gotten here. We've gotten for this. We've gotten for this as well. What is left now is what will be here. Now, at this point, you have 2 minus 2. We give you 0. But at the same time, this is connected to this. And here you have 7 minus 3. Here, we give you 4. That will be here. Here you have 12. 12 minus 8 will also give you 4. So because we are saying we are going to go for the lowest one, between 4, 12, 4, 4, and 0. Of course, we'll go for 0. How? 2 minus 2 gives us 0. Okay, so 7 minus 3 gives us 4. 4 is too much. 4 is greater than 0. And 12 minus 8 gives us 4. 4 as well is greater than 0. So we stop here. With this, you have achieved something. Now, take note. Take note. You have achieved something. If they ask you the next question, if I should go up now and to show you what you were asked to do, one after the other, I think this question is but let me just do where I can do for today. Maybe next time we'll continue again, so I don't overstretch it. I'm seeing my time is running out. I have another 10 minutes. Even if I had more time, I won't be able to go more than this length. First of all, you've drawn the network diagram for the project. You have your mark for that. What we want to look for now is to determine what the critical part. Determine the critical part. So how do you do that? I come back here to the diagram. Take note. Take note of all the areas where you have equal, starting, earliest time, and finishing time. Take note of all of these parts. They are going to form your critical part. So by convention now, your critical part is going to be what? Activity A.
Activity A.
Then you have what again?
Activity E.
Correct. And what next?
Activity G.
Activity G. And what next?
And
Activity
activity
H.
H. So this is
H.
the critical part. You've gotten your answer. At this thing, like I said, it might look a bit clumsy at first, but after now, I promise I will try. I'll give your governor this video. Go and watch it. Go check some. I left some books on the LMS. You go through those books as well. Practice them. There's nothing difficult here, honestly. But you can, if you make one mistake anyway, you've missed the whole thing. That's just the only downside to this. But if you take your time the way you've just done it, you will not miss it. if you are going to make mistake, you will know at the tail end here. What you are supposed to have equal values here automatically. Here as well, you're supposed to have equal values. But if your values are conflicting, then you know that there's a problem. Now, the second question you were asked to find is the determine the minimum time required to complete the project. That one is a given. Based on what we've gotten here, the minimum time is going to be activity A is 2. Am I correct? Activity E
Yes.
is 6. Plus activity G, I think that is 8, plus activity 7. This will give you what? 19. Now, if you may know automatically as soon as you get to this point, you may know. Once you get here, you may know. But you need to show it in the exam. Okay? I've marked so many of your scripts. Some people just get that, but they don't show it this way. Just show it to us 2 plus 6 plus 8 plus 7 equals 9. You've gotten your full mark here as well. Good. Okay? So the next thing you are asked to do here is to what? Determine the following floats for each activity. Now, this one will take me some time to explain to you. However, there are formulas to this. Now, watch out. This is also very easy. Very easy. I'm going to expand this now. Let us take, for example, you will do the rest yourself. Let's take, for example, if I delete anything here, you may need it later. I'm trying to delete so I have some space to. But I hope you are taking down this explanation, because I want to clean off now.
Sir, I thought you give us. We are not taking it down. We want to concentrate on it. So maybe you give us like this, sir.
Okay. So look at this. Now, if you pick activity A, I will just do one for you. So use this one to do the rest. If you pick activity A, let me just pick it and draw it out here. This activity A. This is the starting node. This is the finishing node. If you understand what I'm showing you now, you will never have problem on this thing in the exam. No matter how the question comes, you will get it. Already we have 0 over 0. On the tail end of it, for the purpose of this my explanation, I'm going to delete this for now. Let me just delete this. Okay. Now we have here, you have 2 over 2. Take note, I said the numbers on top, the upper number is your earliest times. Those are your earliest times. And for this is the earliest starting time. The number for this one too is also your earliest time, the upper number or the upper one. And it is your earliest finish time, because A starts from here and finish here. What about the bottom number, the 0? It is your latest starting time. Why? Because this is actually where it's starting from. For AO, for activity A, why over here, it is your latest finishing time. I'm giving you the secret behind the formula, so that even if you don't have the formula, with this one, you can do what you want to do. Now, you've been asked to look for total float, TF. What is total float? We say total float is the time the project can be, an activity can be delayed. Please put your mic off now. the time an activity can be delayed without affecting the total project completion time. The time an activity can be delayed without affecting the total project completion time. What I want to say, I don't want to lose you guys. If you look at this, if this is the latest finishing time, that means this is the last A activity can get to here. This is the last. And you are using the word total. You want to know the entire length of A, the time that A can take. Now, if this is the last, this one here is the first. This is the beginning of A. So the formula for this is just simply the trick I want you to do in your mind, or if you can put it down, just draw an arrow. This is not in any textbook, or I'm just giving you my own way. Draw an arrow that links this to this in your mind or in the examination for TF. Once you can link this to this, you know that you are doing what? You are deducting EST from LFT minus the duration. This is the formula for total flow. Okay? The latest finishing time for activity A minus the earliest starting time for activity A, then minus the duration. So for activity A, for example, the latest finishing time is 2 minus the earliest starting time, which is 0, minus the duration of A. We know duration of A is 2, minus 2. Everything gives you what? 0. Now, this is meaning that A has no time for nonsense. There's no space. There's no free time for activity A. Activity A that is why we refer to it as an activity on the critical part. Every activity you saw me mention, the one I just cleaned off now, please, like I said, have it. Those activities I cleaned off now, they are the critical activities. For them, their total float is 0, meaning that there's no spare time to do any other thing. You must finish those activities within the time that you've been given. That's why they are called critical activities. I will leave this one because I will soon go off in less than a minute, and I won't be on again. But I will tell your governor when we are going to meet this week. I will create another time for you again this week so we can pick it up from there. I'm saying less than a minute, so I will stop here.
A quick one, please.
Okay, go ahead, please.